Hi everyone, welcome to AS Engineering Academy. This is Ramesh Pabba, faculty at AS Engineering Academy. Now in this today's session, we are going to take the entire topic regarding transducers. That is nothing but one of the important concept in the measurement subject, transducers. But in this today's session, we are going to cover the basic ideas regarding the transducers and a special topic I am going to take. Based on that, we are going to take all numerical questions possibly on the corresponding topic. Now let us start the session. That is transducers. The first point here is, what do you mean by transducer? What do you mean by transducer? Sir, the transducer is nothing but it is a device which converts non-electrical energy into electrical energy. Non-electrical energy into electrical energy. So therefore, that device simply called as transducer. So simply we can say transducer is a device that is used to convert physical quantity. It means approximately we can say non-electrical we say. So therefore, it is a device which converts physical quantity into electrical signal, that too corresponding electrical signal. So what do you mean by that physical quantity? Let us take pressure. Let us take force, for example. That force or pressure or any unknown physical quantity should be converted into electrical form. Example, voltage V0. So output will be in terms of electrical. That device is called as transducer. This is a general definition. Physical quantity is converted into electrical signal. Suppose in the purely technical way, transducer is a device which converts. Here I have given the clear-cut type of quantity, non-electrical quantity into an electrical quantity. Therefore, the point is, it is a device which converts one form of energy into other form of energy. It is a device which converts physical quantity into corresponding electrical signal or non-electrical quantity into an electrical quantity. Non-electrical quantity into electrical quantity. Clear? Okay. Sir, here I am showing this is the input we are giving. This is the input we are giving. Right? Input we are giving to the transducer. Right? We are going to get the corresponding output. You are going to get the corresponding output. Which output? See here. Non-electrical quantity is being converted into electrical quantity. This is nothing but transducer in terms of block diagram I am showing. Clear? Okay. But sir, in this transducer block, what are the internal blocks available? What is the elaborated way of the transducer I am showing here? Sir, first I am taking the transducer here. Transducer. Right? It is a transducer in which sub-particles are there, sub-modules are there. What are those? Just I am moving aside, I am showing. See here, one element is sensing element. Okay? Right. Other element is transduction element. One element is sensing element, other element is transduction element. I am moving aside. Kindly observe the total thing clearly. Sir, the moment we are giving the input, that input will be connected to sensing element. Then it will be giving some output. That output is given to transduction element. Thereby we are going to get the corresponding electrical output. This is what the elaborated way of corresponding transducer. Okay. Sir, I am showing here. Input is given here. The input is given. Sir, which type of input it is? Obviously, non-electrical input. And this sensing element gives corresponding output. I will tell you what is it. And a transduction element. Finally, we are going to have the electrical output. This is the step-by-step notation. Clear? Right. Now here, this is nothing but non-electrical input. I am writing clearly. Physical quantity or non-electrical input. Let me try it. Physical quantity. This is the physical quantity. Okay. It will give the corresponding value to the transduction, and this is nothing but corresponding electrical output. But you need to understand very clearly one point. Sir, this is called as sensor. Sensing element is called as sensor. Sir, sensor only senses the corresponding physical quantity. Be clear, sensor will not convert. Only sensor senses and give the corresponding thing to the transducer, the transduction element. So that's why the entire conversion process will be available here. So therefore, transduction element in the common language, we can also call it as conversion element. Clear everyone? Sensing element is nothing but a sensor. Transduction element is nothing but a conversion element. Sensing element sensor, transduction element is nothing but conversion element. Therefore, based on these two very popular question in all competitive examinations in which the transducer topic is there. Yes, even in SSC JE also transducer topic is there. This question is very common, very popular, we can say. What is that? Sir, what is the difference between sensor and transducer? What is the difference between sensor and transducer? Very important point. Sir, sensor means only senses, only responds to the physical quantity. It does not convert at all. But transducer means complete box is transducer. Transducer means it is having sensor as well as conversion element both. So that's why sensor only senses, does not convert, but a transducer means in this transduction element is there, no conversion element is there. Therefore, transducer is conversion device and sensor is only sensing. That's why I am writing clearly here. Senses. Nothing but we can also write, sir, sensor responds to the corresponding physical quantity. Sensor responds to the corresponding physical quantity, but a transducer convert. This is very popular. That's why I'm repeating this point. Okay, now based on this entire block diagram, let us proceed with the differences between these two. What are the thing I have spoken? I'm showing on the screen. Kindly focus here. Sensor and a transducer. Sensor and transducer. What is the clear-cut difference here? What is the clear-cut difference? Kindly focus. Working principle. What is that, sir? Sensor senses the physical measurement and makes it readable for the user, but keeps it in the same format. It will not convert. It will not convert. But here, senses the physical. Transducer means sensor will be there, conversion will be there. So transducer means sensor plus transduction element. Nothing but conversion element we say. TR means transduction element here. Okay. Senses the physical measurement and converts. It is very important. It converts the corresponding value into electrical value. See here, into another form. Example, non-electrical into electrical. This is the clear-cut difference between sensor and transducer. Okay. So based on this, I am framing two questions. Those who are on the line, kindly try to answer. Right? So what is that? Be clear. Sir, here, first statement. Kindly tell me it is true or false. Okay. Sensor is a transducer. Sensor is a transducer. This statement is true or false? Kindly take 30 seconds of time and try to answer. Sensor is a transducer. Sensor is a transducer. Now tell me, is it true statement or false statement? Come on, guys. Right, try to give the answer. Right, be clear, guys. Sir, yes. Very good. Mohini, false. Very good. Sumit Pawar, false. Pravalika, false. Amar Mirza, yes, you have given. Yes means is a true or false statement. Very good. Here, sensor is a transducer is absolutely false statement, sir. Why? Transducer is a conversion device, but sensor is not a conversion. Suppose if you say sensor is a transducer, it means sensor is also a conversion device. Is it? No. So that is the reason why answer here is this statement is straight away false. Clear? Now, in the same way, second question I'm giving, second statement. Transducer is a sensor. Transducer is a sensor. Now tell me. Yeah, Amar Mirza, right, you have corrected your statement, correct. Now tell me this one. Transducer is a sensor. Is it true or false? Come on. Right. Pravalika Lakshmi, true. Others? Very good. Mohini, true. Others, kindly try to give the answer. Sumit Pawar, false. Why? Kindly check it. Amar Mirza, true. Right. Okay. Right. One student gave the false answer, but be clear. Transducer is a sensor. What is sensor? Sensing. Transducer senses or not? Check it here. Transducer. Transducer senses and converts. So therefore, transducer is a sensor obviously. But a sensor is not a transducer. Don't get confused. That's why I told you this is a popular question. Transducer is a sensor. Of course, this statement is obviously true. Is it clear, guys? So this is a simple idea regarding transducer basic definition, and based on the definition, the possible questions in the SSC JE level. Okay, right. Now, let us go. Yeah, Sumit Pawar. Okay, right. Very good. Very good. You have corrected. Right. Now, the next one is, sir, transducer classification. Sir, once we know the definition, we should know about the types of transducers. So, what are those types of transducer and all? Let us see. These transducers can be classified. These transducers can be classified based on different categories. One is based upon transduction principle. Be clear, I told you. Transduction meaning itself is a conversion. Means how the non-electrical quantity is being converted into electrical quantity. Based on that, yes, the conversion process based the types of transducer. This is one category. Second one is as a primary and secondary. Means the transducers can be classified as primary and secondary. What is that? I'll tell you what is primary, what is secondary. And we can go in terms of passive nature, active nature also. Passive and active transducer. Of course, you know, very well known to you. Passive transducer. What do you mean by this passive transducer? Passive. What is the meaning of passive element? Which requires power supply for its operation. Same thing here also. But active. Active means which generates the power on its own. Those are called as self-generating type. Yes, active transducers are self-generating type. Based on that active passive definition only, the transducers are available. Next, analog and digital. This is very, very simple. If the output is in the form of analog transducer, output is in the form of clock pulses or pulses, that is simply called as digital transducer. Very simple. Finally, very, very important, the transducers are classified as transducer and inverse transducer also. What do you mean by transducer, guys? Non-electrical conversion. Non-electrical is converted into electrical. Inverse transducer means exactly reverse. Electrical quantity is being converted into non-electrical. That is called as inverse transducer. This is the basic classification of all transducers. Clear? Now let us take one by one. Sir, based upon transduction principle. But all I told you, transduction means conversion. Based on that, the thing will be available. Let us see here. So first one, based upon the transduction principle. Based upon transduction principle. Right. In this again, so many types are there. What do you mean by that? Based on the conversion, how it is converted, on what basis it is converted. So different parameters are there. What is that? It may be resistive based, resistive transduction, inductive based, inductive transduction, capacitive based, capacitive transduction, piezoelectric transduction, or photoconductive transduction. Like that, different types of conversion principles are there. Before that, be clear. I told you, no, transduction, already told you, the transduction element converts the output of the sensing element. In this I gave clear statement. The non-electrical quantity is given to transducer, means connected to sensor. Sensor output is given to the transduction element. That will be converted to electrical. That's why the transduction element converts the output of the sensing element, into an electrical signal. Output of sensing element into an electrical signal. That's what the simply transduction, nothing but simply conversion element. Clear? Right. Now let us see. Here, resistive transduction. Resistive transduction means very simple, guys. Resistive transduction means the non-electrical is being converted into electrical based on the resistive principle. Next one, induct. Next one, capacitive. So all these three are called as generally passive. Why? RLC. RLC elements are passive. Therefore, these transduction principles or these transducers come under, what is it? Passive transducer category. Okay. Next, piezoelectric transduction. Piezoelectric transduction. Nothing but based on the piezoelectric principle, the corresponding transduction will be there. And finally, photoconductive transduction. Photoconductive transduction. These many types of conversion processes are transduction process are there. Okay, now let us see. Sir, what is resistive transduction? Just a brief idea I am giving. The first one here is resistive transduction. Right. Sir, what do you mean by resistive transduction? Very simple. Suppose I am taking one physical quantity. Let me take displacement. Okay. We are giving the change in displacement. Yes, we are applying the non-electrical input. Okay. This displacement is converted into change in resistance. Means based on the change in displacement, we are going to get the change in resistance, and finally we are going to get corresponding electrical output. That is what called as resistance transduction. Means the moment we apply the non-electrical input, then internally resistance change occurs. Due to that resistance change, corresponding electrical output will be there. This is called as resistance transduction. Okay. Now second one. Simple. If you understand one thing, others are very simple. That is inductive transduction. Inductive transduction. Very, very simple, guys. Same thing. Displacement is given. Based on the displacement, change in inductance, either self-inductance or mutual, but I'm writing self for example. Based on this, corresponding electrical output. Very, very simple. Right? Means what is the main role? Change in resistance, resistance transduction. Change in inductance, inductance transduction. Very simple. Next. Third one is capacitive transduction. Capacitive transduction. So what is this capacitive transduction? Very, very simple again. Suppose I'm taking displacement, right? It will be converted into right? If you keep on applying the displacement based on the change in displacement, change in capacitance occurs. Based on this change in capacitance, obviously corresponding electrical output will be there. Right, next, piezoelectric. Piezoelectric transduction. Piezoelectric transduction. What is that piezoelectric transduction? Here simply, right, we are applying some force, but the two in this piezoelectric principle, this force must be dynamic in nature. This force must be dynamic in nature, and thereby we will be getting change in charge produced. This principle is called as piezoelectric principle, and based on this, corresponding electrical output will be there. Based on this, corresponding electrical output means due to the applied force, due to the applied dynamic force, the charge will be taking place. Charge will be established in that, we can say. Due to that charge change, corresponding electrical output will be there. This is what piezoelectric transduction. Right? Now, finally, photoconductive transduction. Photoconductive transduction. All these are basic points, but directly based on this question will be there in the SSC JE level. Okay. Sir, in this, what is the input? You know, light intensity, we can say. If you are varying the light intensity, right, change in resistance occurs. Nothing but if you are varying the light intensity, automatically, right, change in resistance occurs. Due to this change in resistance, obviously corresponding electrical output will be there. Obviously, very, very simple. Light intensity giving the corresponding change in resistance and giving the electrical output. But my question is, sir, if you are changing the light intensity, how the resistance will be changing? If you are changing the light intensity, how the resistance is changing? Anyone? Can you tell me? Those who are on the line? If you are changing the light intensity, how we are going to get the corresponding electrical output, anything but corresponding change in resistance. Everyone tell me, which device or which element we are supposed to use? Try to answer. Right? Nothing but simply we are going to use LDR, light dependent resistor. Light dependent resistor, LDR. Okay, so this light dependent resistor, nothing but based on the light intensity variations, change in the resistance occurs. Based on the change in resistance, corresponding electrical output will be available. This is the example for photoconductive. Clear? Right? Now, just go back once. Here, all resistive, inductive, capacitive, piezo and photoconductive. So therefore simply, right, LDR, light dependent resistor, we can say. Right? This is transduction principle. After that, very, very simple. Primary, secondary, passive, active, analog, digital, transducer, inverse transducer. Very, very simple. Let us have, right, that also. Right here, sir, primary and secondary. Very simple. Transducer, I am dividing into or making that into two stages. Transducer, I am making that into two stages. What is that, sir? Here, right? One is mechanical device. Second one is electrical device. Okay. The moment we give the input, that will be connected to mechanical device. This output will be connected to electrical device and corresponding electrical output will be available. Nothing but this is completely transducer. But if you are making them into two parts, one becomes mechanical part, one becomes electrical part after that. Sir, here physical phenomenon. We are giving which one? Physical phenomenon we are giving here. Based on this physical phenomenon, it will be giving the corresponding mechanical output. Based on this mechanical output, we are going to get the finally electrical output. This is what the corresponding point. Okay, after that, this mechanical part, nothing but first stage conversion, physical quantity into mechanical. So therefore it is a primary. And this is the second stage. Therefore it is called as secondary transducer. Check it here. It is called as primary transducer. It is called as secondary transducer. Now tell me, primary transducer converts dash into dash, means physical phenomenon into mechanical. Secondary transducer converts mechanical into electrical. In the same way, primary or mechanical both are same. Secondary or electrical both are same. That's what the simple point. Okay. Now here I am giving one small example here. Right? Example for this one is, right, Borden tube. Just simple one example I am giving. Borden tube and LVDT. Borden tube and LVDT. Sir, Borden tube, right? Borden tube converts pressure into, I am giving here pressure. So what is our physical phenomenon? Pressure. If you apply the pressure, this Borden tube is a device which gives displacement, here. And this displacement is converted into which one? Electrical output. This is what the actual point. What is it? Pressure into displacement, displacement into corresponding electrical output. Very, very, very simple. Clear? So therefore, this is called as mechanical transducer or primary transducer. This is secondary transducer. Very, very simple. Here this is primary transducer and this is secondary transducer. And in the place of Borden tube, some more devices are there. In the place of this, we can use bellows also. We can use bellows, right? Bellows also same function. What is it? Pressure into displacement. Or diaphragm also we can say. Diaphragms also same thing. After that, again, LVDT is common. LVDT is common. Like this, I am showing. So these are the things related to primary as well as secondary transducers. Clear everyone? Right. Now, next one. Passive and active. This is very, very simple. So passive transducer means it requires external power supply for its operation. Example, resistor, inductive, resistive, inductive, capacitor. And active transducers mean they are having the self-generating capacity. Therefore, they don't depend on external power supply for their operation. Example, we will be having thermocouple and solar cell, photovoltaic cell, etc. So many other. Piezoelectric transducer also comes under active transducer only. You are going to get the question like, which of the following transducer is a passive transducer? Which of the following transducer is an active transducer? In that way, the questions will be given. That's why focus more. Here, passive transducer. These derive the power required for a transduction from an auxiliary power source. Means for conversion purpose, means for its operation, these require power. That's why these will derive the power from some other source. That is what? Yes. What is that example? Potentiometer, LVDT, microphone, etc. Or we can say in the simple way, resistive, inductive, capacitive transducers. Very important, especially from this transducers chapter, transducers part, you are going to get most of the cases conceptual questions. Which of the following is this? Which of the following is coming under that category? Or match the following. In that way, the questions will be given. Right. Next, active, exactly opposite. Active transducers do not require, those are self-generating, check it. These do not require an auxiliary power source to produce their output. These do not require. Simple logic. If you know from the fundamentals of electrical engineering what is passive, what is active, same definition. That's it. Their element here transducer, only that is a change. Now, these are called as self-generating. These are called as self-generating. And examples, piezoelectric transducer, photovoltaic cell, thermocouple, pH electrode, etc. All these come under, all these will come under active transducer. Clear? Right. Next, right? Transduction based over, primary, secondary over, and passive active over. Next one is analog and digital. Analog and digital trans. Very simple. If the output is in the form of analog, yes, that is analog transducer, right? These transducers converts the input quantity into an analog output, which is a continuous function of time. Of course, analog means continuous function of time. Examples, LVDT, thermocouple, etc. all comes under analog type. Now, digital means very simple. These will convert the corresponding input quantity into an electrical output, which is the form of pulses. Means whatever the transducer which gives the output in the form of pulses, that is simply called as digital transducer. Right? Now, next, last one here is transducer and inverse transducer. This is very, very simple. Transducer converts non-electrical to electrical. Okay. And inverse transducer converts electrical to non, exactly reverse. See here, transducer, right? What is a transducer? Already we know, non-electrical into electrical. Of course, already we have taken. Now, second one. Sir, inverse transducer, what is that? Electrical into non-electrical. Electrical into non-electrical. Very, very, very simple. Okay, but here, what is the example? What is the example, or what are the examples of this? Now, I am giving one example. Be clear. Piezoelectric. Whatever the piezoelectric principle is there, it acts as transducer as well as inverse transducer. You may be getting the question like, which of the following is behaving like transducer as well as inverse transducer? Means, yes, piezoelectric transducer is one of the options. Okay, sir, to the piezoelectric transducer, if we give the dynamic force, electrical output will be there. If we give the electrical input, obviously corresponding, what is the displacement will be the output. Non-electrical is the output. Vice versa, conversion is there. That itself is called as piezoelectric principle. Therefore, it is example for both. But second one is very, very, very important here. Suppose I am speaking. What is my signal? Sound signal. So therefore, sir, sound signal. Right? Now, I am speaking through microphone. Okay, this sound signal is converted into electrical signal. So therefore, sound signal is converted into electrical signal. Right? Through which one? Microphone. Nothing but, yes, here we are using microphone. Clear? After that, that mean you are hearing my voice through speaker or loudspeaker, we can say. What is it? Electric signal is converted back to the corresponding sound signal. So therefore, what we can write now? Electrical signal converted to which one? Sound signal. Electrical signal converted to sound signal, right? Through which one? Speaker, or generally we say loudspeaker also we can say. All these are the concepts related to the transducer, which are related to types of transducers and all. But be clear, this is non-electrical to electrical transducer. This is electrical to non-electrical. Which one? Inverse transducer. This is the simple concept. So based on this, let us have some questions. Sir, what are those? Be clear. Here, right, Okay, before taking the questions, just I'm giving the corresponding transducers list and all, then we'll be taking the questions. It will be more clear. Sir, resistive transducer, whatever the resistive transducers available, I'm going to show everything, right? That is what these many types of resistive transducers are there. I'm moving aside. Yes, you can observe this clearly. What is that? These are the corresponding electrical parameters and class of transducer, which type of transducer, and here what is its application. From these table like that, I'm going to show resistive, inductive, capacitive, and then active, self-generating. 4 boxes I'm going to show. From these only in the SSC JE level, many number of questions are possible. Many number of questions are possible. What is it? See, sir, potentiometer. Sir, potentiometer, right, converts dash to dash, nothing but typical application, nothing but potentiometer for which measurement means pressure measurement or basically displacement measurement also we can say. Right? So simply you are getting the question like, sir, what will be the corresponding measurement possible with the potentiometer or potentiometric resistance transducer, etc. Yes, displacement measurement we can say. Right? Next, resistance strain gauge. Sir, it is a strain gauge. Strain, nothing but stress strain always. Related words, stress strain. How do you get the strain? How do you get the stress? Means force by area is nothing but stress. Once the stresses are developed on the body, what is that? Deformation takes place. That is simply, in the simple way I'm giving, strain we say. So that's why the strain gauge, the moment you observe the strain gauge word, automatically you need to understand that force measurement based on the force, displacement, yes, displacement measurement also possible. These two are 2 questions in 2 different papers we can say. Next, Pirani gauge or hot wire meter. Pirani gauge or hot wire meter. These are for gas flow or pressure. Very popular question. The pressure measurement is done by dash. One of the options will be Pirani gauge. Or Pirani gauge is used to measure dash pressure measurement, in that way, or gas pressure measurement. And resistance thermometer is very simple. Sir, very simple point here. Thermometer. Therm itself indicates heat. Heat means temperature. Obviously, temperature measurement. Or radiant heat, etc. Temperature measurement. Okay. See, I am giving one by one means all the points I am giving as a summary. You will be getting all these points here and there, topic wise, chapter wise. But in this important concept session for SSC JE module, I have collected all the things and I am showing at one place. To get all the things at one place, it will be very easy to you. And thermistor, it is also therm. What do you mean by therm? Therm means temperature again. Yes. Temperature. But sir, flow measurement is also possibly thermistor means actually thermal principle. Yes, flow measurement is also possible. Sir, how? Suppose one pipe is there. Through this pipe, some liquid or gas or fluid, something is flowing, for example. That flow we need to measure. Now tell me, based on the flow, we need to get the corresponding output. Sir, how? Means in this pipe, we will be keeping the heating element. Heater we say. If that flow is through the heater element, based on the flow velocity or based on the flow discharge or simply based on the flow, the temperature will be changing. Okay, due to that temperature change, resistance of that element will be changing. Based on that resistance, electrical output will be. So therefore, yes, flow measurement is also possible with the thermal principle or thermistor gauge we can say. And resistance hydrometer. Sir, hydrometer for which one? Humidity. Hydrometer is for humidity measurement. And photoconductive cell. So this is acting as photosensitive relay. All these are coming under which category, guys? Resistive transducer. All these are resistive. Sometimes you may be getting the question like, which of the following comes under resistive category or resistive, inductive, capacitive? List 1, other side list to some other will be there. So in this way the questions will be given. Right? Now let us take inductive transducer. Let us take inductive transducer. Sir, in this inductive transducer principle or based on inductive principle, which transducers are there? Be clear. Sir, magnetic circuit of course inductive itself indicates magnetic phenomena, so therefore magnetic circuit transducer. This is for pressure measurement, displacement. Be clear. Resistive, inductive, capacitive, all the three are for displacement measurement commonly. That's why displacement. Why? We apply the force or we apply the pressure internally, which will be happening, displacement only. Yes, that measurement is generally possible. And reluctance pickup. Sir, reluctance is the word related to which one? Magnetic circuit. Magnetic circuit means inductive phenomena. That's why reluctance transducer also comes under inductive. But sir, here pickup is given. Actually, transducer is also called as a pickup. So therefore, wherever you are finding the word pickup, it indicates transducer only. Where you are finding the word pickup, that indicates transducer only. Clear everyone? So simply it is a transducer. Yes, it is a pickup notation. Okay, right. Sir, it is for pressure measurement, displacement measurement, vibrations or position. All those can be measured with the reluctance. Simple logic, guys. Suppose one coil is there. One iron piece we are placing. Suppose if I keep on moving the iron piece near to this coil or away from this coil, reluctance is changing or not? Based on that reluctance, flux linking will be changing. Based on that flux linking, corresponding electrical output will be changing. Therefore, yes, with this reluctance, simply displacement can be measured. Yes, I am applying the displacement, or I am applying the force, or I am giving the position. Yes, everything is possible. And differential transformer. This is the very, very biggest topic in the, what is the GATE or ESC level. But for you people, direct objective questions are there in the SSC JE level. So differential transformer mode, we are having two types, LVDT and RVDT. In the earlier topic I told you LVDT, but what I told you there, displacement is converted into electrical output. Yes, but L means linear, variable, differential transformer, nothing but if we apply the linear displacement with the corresponding transformer approach based on the differential concept, electrical output will be there. RVDT means rotational, means angular displacement. Both are displacements only, but one is linear and one is angular displacement. And it is also pressure, force or displacement. Yes, obviously the name itself indicates linear displacement measuring device, angular displacement or rotary displacement measurement, etc. Next, eddy current gauge. Eddy current is also related to magnetic circuit, means inductive phenomenon. Eddy current is also, yes, displacement measurement. That's why I am giving the simple hint to follow. Resistive, inductive or coming one, capacitive. All those are generally for displacement measurement every time in general. Right? Next, magnetostriction gauge, that is for force, pressure, sound, etc. All these are for corresponding which one? Inductive notation. Right? Now, next one is capacitive transducers. So what do you mean by capacitive transducer? Means if we apply the non-electrical input, capacitance value should be changing. Based on that capacitance change, electrical output should be there. Same story. Okay. Now here, sir, what is this? Variable capacitance pressure gauge. Nothing but the name itself indicates pressure is given. If we apply the variable pressure, automatically, yes, corresponding electrical output. That's why this is for either displacement or pressure. And capacitor microphone, speech, music or noise. Speech, music or noise, all can be measured with the capacitor microphone. And dielectric gauge, In the earlier case, eddy current, but here dielectric. Why? Between the two capacitive plates, whatever the material we are placing, that is dielectric material only. That's why dielectric gauge comes under which one? Capacitive. Therefore, liquid level or thickness. Simple logic, guys. Suppose two plates are there. Okay, two plates are there. Between that, whatever the dielectric material we are using, if you are changing that dielectric material, changing the material or changing the position of the dielectric material, automatically capacitance will be changing. Based on that capacitance change, electrical output will be there. That is called as dielectric gauge. So all these are coming under capacitor. But it's easy to observe capacitance. It is straight away. But you need to understand that dielectric material means obviously which one? Corresponding capacitive principle only. All these are related to capacitive transducers. Right? Now, next one. Sir, here, what is that? Self-generating, or we can say active transducer. Now tell me, in the earlier three cases, either resistive or inductive or capacitive, assume that I applied the displacement. If I apply the displacement, be clear, if I apply the displacement, what will be changing? Resistance change in the resistive transducer, inductance change in the inductive transducer, capacitance change in the capacitive transducer. Okay, but that resistance change or inductive change or capacitive change should be giving the output as electrical. How is this possible? Can the resistance generates its voltage? No. Can the inductance? Can the capacitance? No. There we are supposed to use a separate supply. So therefore, those need external power supply for their operation compulsory. But here these are self-generating, that is active transducer. These do not require any external power supply at all, because these are self-generating. That's why be clear. All these are coming under active transducers. Okay, sir. Thermocouple and thermopile. Sir, thermo means temperature. So therefore, these are for temperature measurement. Or heat flow or radiation. Yes, all these are for temperature measurement or heat measurement, we can say. But in this thermocouple, we need not to give any external supply. That's why it is called as active. Active means self-generating. Right? Next, moving coil generator. The name itself indicates generator. It does not require any other. So therefore, this is for velocity and vibration measurement. And piezoelectric pickup. All I told you, pickup means transducer. And piezoelectric is a transducer as well as inverse transducer, I told you. In the same way, piezoelectric pickup or piezoelectric transducer does not require any external power supply for its operation. Okay, right? So this is for which measurement? Vibration, pressure changes, etc. Sound, vibration, acceleration, etc. Generally, pressure or force measurement, generally we prefer more and more here. And photovoltaic cell, or simply solar cell, etc. we can say. Yes, light meter or simply these can be used as the solar. What is that? Solar energy conversion into electrical. Does it need any external power supply? No. That's why all these are coming under which category? Active or self-generating category. Clear, everyone? Right. For your understanding purpose, just I'm moving aside and I'm showing, kindly observe this, complete resistive transducers. Complete points I'm showing on the screen. Just observe it. And next, inductive transducer. All together I'm showing. Right? For more clarity, I'm moving aside. And third one, capacitive transducer. Right? Next, finally, active transducer. Okay, these are the corresponding transducers, and I told you, basics and corresponding topic, resistive, inductive, capacitive, as well as self-generating. Now, let us have few questions on this. Sir, what is that? Which of the following options is an active transducer? Nothing but which of the following is an active transducer? Now, observe all these things, right? Whatever the examples we have taken earlier, which is there? Sir, photovoltaic cell is there, automatically it is simply active. So therefore, this is active. Other things are coming under passive only. What is it here? Photoemissive cell, etc., or photovoltaic cell, another cells in it, simply, right? Cells in or photoemissive cell, all these are not active. Only photovoltaic cell active. So straight away, it comes like, yes, active cell. Okay, right. Next one. Match the list 1 with list 2. List 1 is the quantity, list 2 is the transducer, and we need to match them. So list 1, list 2 like this. Force, torque, acceleration, spiral spring, flat spiral spring, seismic mass, and cantilever beam. Like this options will be given. Now, sir, I am giving 30 seconds of time. Kindly try to match and respond. Sumit, it is a type of inductive transducer. It is a type of inductive transducer. Synchro, right? Synchro transmitter, synchro receiver, related to that family. Okay, right. Come here and tell me. Force measurement, torque measurement, acceleration measurement. Or for your understanding purpose, I am showing the corresponding numbers also. Kindly try to answer, guys. Try to answer. Try to choose the key. Try to choose the key. Come on. Right, respond. Force, torque, acceleration, spiral spring, seismic mass, cantilever beam. Anyone? Try to give the answer. Right. Okay, people are typing, it seems. Be clear, guys. Very simple. Sir, here, force measurement is done by cantilever beam. Right? Cantilever beam, if you apply the force, by balancing it, we are going to get the force measurement. P3. Where is P3? So, therefore, this is wrong, this is wrong. Two options. Next. Sir, torque measurement. Torque means angular. So simply you can see here spiral. Yes, that is angular only. So therefore, so simply torque is here. What is that? Q1. Yes, Q1. So it is also wrong. So obviously option C is the answer. Among all this is the matching. And R is anyway 2 only. Right? R is anyway 2. Acceleration, seismic mass. In this way also, the questions will be given in general. Right? Next question. Right. Thermocouples are dash. Thermocouples are dash. Tell me, guys, what is thermocouple? Thermocouples are, first one, active transducers only, passive transducers only, both active and passive transducers, output transducer. No way. So simply passive wrong. Both active passive, it is also wrong. Output transducer, we cannot say directly. So simply what we can say, yes, it is an active transducers. Right, Sumit Pawar, option A. Very good, very good. Clear? Right. Those who are given wrong answers, I'm not naming them, just try to correct it. So this is the total thing related to the entire important concept related to measurements. In the first day we have taken error analysis, basic instrument. Second day, that is yesterday, we have taken CRO and DVM, and third day we have taken transducers. But all I told you, the entire session for 3 days is only purely related to SSC JE level. So that's why focus more. And who are listening this, kindly concentrate. You might have completed gate coaching or something, etc., gate preparation, everything, by thinking that don't go into much depth in terms of numerical or etc., and don't get confused. SSC JE level will not be that much high. So simply in the gate, in-depth numerical derivations, ESC derivations, etc. are required. But in this SSC JE model, concept and corresponding question and little bit small numericals will be there. That's why I am closing this entire, what is it, measurement important concept session for 3 days, right? And finally, I am wishing you all the best for your entire preparation. Thank you guys.